Hi everyone, good afternoon. Can you guys just confirming that you can hear me? Okay, great. So first of all, thank you so much for skipping out on lunch and joining this talk. I'm hoping that I'll make it worth the while. My name is Shwetang Sheel. I work at Rackspace. I've been doing data and analytics pretty much my entire life, a lot longer than it's been cool. Back in the day when we used to have 10, 20 people show up to an event like this, and now it's exciting to see what's happened here. So as I said, I've been doing analytics my entire life, and I built a company which did that. I sold that company to Rackspace, and over the last 2.5 years, what I and my team have been focusing on is about how to reimagine the work that we do in data platforms and data products with the advent of AI and Gen AI. And what I want to take you through in 3 parts, I want to illustrate the problem that we seem to be ignoring when we are using AI to solve building data products. I then want to talk to you about our approach to the solution, how we are reimagining this, and then I'll showcase to you certain aspects of that as we have been actually trialing it with certain sets of large pilot customers when we're doing that. And hopefully that's going to generate interest. If we have time left, I'm happy to take questions. Otherwise, I'll put up the booth I'm at to be able to talk about this in more detail, right? So starting off with the problem statement, right? The numbers on top are very large, but those are only to represent that data engineering and building data platforms, whether those are for the purposes of BI, for the purposes of agents, or for the purposes of applications, is a very large market. And we do see that the majority of those projects, including projects that we run, tend to fail. And the definition of fail here essentially is if you are more than 3 months off from when you were supposed to have delivered your data products to when you actually did it, that comes up, right? And what happens is, interestingly, that if you break down the life cycle of a data product into 3 broad categories, there's one category around doing sort of requirements in design, figuring out what is it that I want this data product to do, what answer do I want the BI report to do, what information does the AI agent need, etc. That's one large bucket. The second large bucket is actually building it out and then deploying that into whatever platform that you're using right now, whether it's Snowflake, Databricks, AWS, Azure, Google. And the third is actually managing that, because you have to continue to get value from that. It's not just being able to answer that question once, it's about being able to do that on an ongoing basis. Now, we see a lot of focus in the build and deploy. As you go around, you'll see a lot of companies, a lot of ISVs, a lot of the platform providers focused on how do I generate code to be able to build an ETL pipeline or build out a table, etc. But it's the other two, identifying what is the actual question, what is the spec. All of you are probably familiar with spec-driven vibe coding now, where you have to define the spec so that agents can go ahead and build that. What is the spec that you should define to be able to get the right outcome? And this is a Fortune 50 healthcare company. These guys have, I think, somewhere in the range of 2,500 data engineers as part of their central data platform team. They've spent millions of dollars building out their data platform, and the biggest tent in the pole, the thing which is always the sticking point, is doing source to target mapping. For those of you who are data engineers who will be familiar with this term, essentially being able to define where do I get information from and what is the logic that I use to transform that. That process is still fairly manual, right? And if I illustrate this point with an example, I can't take the customer's name, but I'm happy to talk to you about this one-on-one. But this is a classic example of what we mean by actually being able to have context and knowledge when we go in. So this is a retailer. The VP of sales, really experienced guys, 20 years in the industry. His statement was that, I know that customers who have lower engagement churn within 90 days. That's the request. I want to get a list of customers who are likely to churn because they've got low engagement in 90 days. Now, if you think about, this is actually what happened in this project. That request going over to the product manager got taken note as track customer engagement. So we lost quality because we were meant to do this only for quality customers. What is the definition of quality got lost there, right? Next, what got created in the data contract was that I want an engagement score. So again, here it's become an absolute number as opposed to a comparison over time. What you're trying to measure is what has gone down, right? When that goes over to the developer who's creating this, the developer used login to see whether you're logging. That's very good, until you consider that most enterprise customers use automation. They're not logging in. So logins is a bad idea or a bad metric to determine engagement for enterprise customers, but it is a good value for medium-sized customers who manually log in. And that data then gets used in building out an ML model where the fact that all that data is in UTC and doesn't take into account that large enterprise customers are actually across time zones. So what's being counted as low engagement for a good customer is actually their nighttime hours, doesn't get into it. And thus what you end up with is a fail where yes, you built a model, each step has met the previous step's requirement, but sort of like Chinese whispers, you've lost the context, right? And because you've lost the context across each of these, you essentially are not able to build out good data products. And that is why it becomes important. As we've been doing this, we've realized that the importance comes in the chain of being able to maintain this knowledge. And agentic AI and agents become valuable only when you're able to provide this context, right? And again, I'll reiterate this because we see a lot of demos around data engineering agents, agents which answer questions, etc. Foundationally, building data products, you can call it data engineering, data products, it is hard. Most of the times we see demos which are very simple, and I've taken sales because I think sales is something that connects with everyone, everybody understands this. Most of the time you see, for example, what is my customer's revenue in the last 3 months, or which opportunities do I have with this customer? But if you take an example like, why don't my bookings in Salesforce match my finance information in my ERP? And here the interesting thing becomes that if your question can be answered by just one screen, likely that application already has an agent or a co-pilot that can answer that question. The value in most of the work that we end up doing is where you have information which is across multiple instances, multiple systems, is across time period, etc. that needs to be done. And that's why if we think about this, if you think about all the stages that have to go through the life cycle of a data product, there is a lot of work happening around transformation, deployment, and operations in terms of being able to use automation and AI. But the pieces on top, which are driving what is the impact or the effect of the quality of the code that you're generating, are still largely manual. And what we are trying to do, the reimagining that we are doing with customers, is to say actually it's most important to have a chain. For those of you who are attending the Gen AI talks, you'd hear about context engineering. Used to be prompts, now it's context. The context form across the entire line becomes sort of the most important inside here, right? And interestingly, what's happening, and I'd be interested to see if you guys agree with this or not, is that traditional vibe coding compounds the problem. I've got 2 screenshots here. One is people on LinkedIn who are now saying that they're vibe coding cleanup specialists, and another one which I browse Reddit very often, where somebody was saying, I think this was on I think Snowflake or GCP. They used generated a query, ran that query, didn't have the right set of filters, so they ended up having a 2,000% increase in their bill for that month because it went and did that, right? Again, the problem here isn't the LLM. The problem here is the amount of context that you're giving the LLM when you're trying to answer a question, right? And thus, if we come to this, we're calling our reimagining Guzzle 2, because the company I used to run, Guzzle 1, was our first attempt at automation before AI. Now we are reimagining that with AI. Because we see that there are sort of 3 broad types of players, and these icons, the logos are not representative, they're indicative only. But you've got all the major analytical platforms which are giving you, likes of Snowflake, Databricks, etc., and Copilot, which are giving you the ability to answer a question. But that presupposes that the data is available in that platform, that data is correct, and also that there is a unified definition of that data. There's a unified definition of country revenue versus country booking, for example, right? Then you've got all these vibe coding platforms which make it much easier for you to generate code. We are also now, with the likes of Agent OS, Kiro, etc., moving into spec-driven development. So don't just ask a question, actually define a spec. But again, defining that spec is disconnected, because every time you're building a data product, you are building that, you're writing the spec for that in isolation, and you're building that out. And once it is built, that spec goes away. The folks who are running this and managing this in production are not referring to that spec about how to do changes, how to do development, etc. And then we've got a host of new, AI startups, which are focused on actually solving the problem that I'm saying. The only distinction is that they are focused on doing that within their platform. So you go ahead and build that in, which leads to one problem that almost everybody, and I'd be interested to see if someone here isn't, has one of those 5, whether it's Databricks, Snowflake, Google, AWS, or Azure, anyone in the cloud has a data platform of some sort with one of those 5. So if you have existing investments, then how do you stand up a parallel platform which is going to have data products separate from the investments that you have? So our process is, or our reimagining is mainly three things: aligning business definitions, capturing institutional knowledge, but doing that on the existing platforms that you have in your environment, the existing data platforms that you have in your environment. And if I was to explain this a little bit further, how do we think about this, right? So this is, how does this ecosystem evolve? Now the first thing is that we've got sort of business questions, and from business questions, we have a set of agents which focus on doing AI-enabled data engineering. Now I'm using the term data engineering here a little bit liberally, because if you see the names of these agents, that also includes the requirement breakdown agent. That means actually talking to your users to understand, I have a screenshot here in a second, but typically the initial requirement that comes in is a very vague requirement. I want to know how my suppliers are doing. What does that mean? Does that mean on time? Does that mean quantity? Does that mean revenue, etc.? So actually going from that context, being able to break it down using industry benchmarks or processes. The example I have will go with APQC to say what is everything that you should be measuring, etc. Breaking that down, giving that so that any of the regular coding agents, and there are plenty of coding agents to generate code, can be used to generate code around that, right? And you can see in the sort of round circles, we've got sort of what is the kind of impact that we've seen. And numbers that I'm showing you here are based both on internal conference room pilots as well as 2 or 3 pilots that we are right now running with some customers, and the screenshots that I have later are from those pilots. But you see the main driver here becomes faster requirement analysis and faster onboarding from a data perspective, right? And the second set becomes AI-enabled data quality. Now inside here, I want to make the point that I'm not talking about technical data quality. Technical data quality, again, I think is fairly well documented, and that, by that I mean sort of not null data types, ranges, etc. I'm actually talking about functional data quality. So saying, for example, I have a header and I have a detail, and the sum of values in header should be equal to the sum of values in detail if I look at the correct time period, etc. Those sorts of data quality rules that come into play. And interestingly, if you see the agentic insights, what we're saying is that we don't want to focus on actually answering the business question. Because again, everybody here, I assume, and I'm happy to hear from somebody who doesn't, has investments in one of these tools, which is answering business questions. What we want to ensure is that the tool that you guys have invested in is actually able to give trusted answers based on the data platform that you have using the data fabric. And the end of that flow comes into management. Because again, when you're managing, there are 2 kinds of failures that come up in managed services. There are the typical failures around my pipeline failed to run because an API failed. But the bigger problem and the bigger time eating comes up when a number doesn't match a user's expectation. So there is a sales report, and the sales report is saying 97 million sold last month, and the user says, I expect it to be 95 million. Why is there a difference of 2 million? Those kinds of things are where we say that the time to resolve those kinds of errors really goes down if you actually carry the context about why. Why did we do a particular join? Why did we use particular tables? Why did we apply a particular filter? What was the decision taken at the time of defining this data product to go about doing this? So to be clear, what we're talking about here is how to use AI agents to build data products in your data platform. And then those data products can be used by AI agents, they can be used by humans, they can be used by applications, they can be used by BI, however you want to use them. Make sense? Now, that brings me to how we've been reimagining this. Again, I'm calling what we've been reimagining as Guzzle 2. And there are a couple of different, my formatting seems to have gone off, but a couple of different key aspects that go into here. One aspect is business intent. And again, as I said, typically when you're talking to senior business users, you get a fairly vague requirement, and you need to go through the process of actually breaking down to get to that. You've got specification, build, and refinement. Again, I think a couple of months ago, this was still new, but now using specs to do vibe coding, where you're not just asking a question, but you're defining a spec and you are passing that to coding agent has become standard. So again, those are artifacts that you actually have to create. And the golden test definition becomes key, because you're not starting off by giving a requirement, you're also starting off by giving an example of the output. So the agent can iterate, the agency of the agent comes in iterating through until that golden test is actually matched given the requirements. And then we talk about the analytics engineer, there's a lot of work that happens in data mapping to try to figure out where in SAP or where in Dynamics or where in Fusion does this information or data come from. and again, simulation and production deployment. And I will talk about production deployment in a minute, because we have a very opinionated view about what options we should give analytical engineers and what options we should not give analytical engineers in order to be able to run a system that is sound and scalable and can actually result in people not having to get a call at 2 in the morning, right? So let me take you through a few examples. Now, what I'm going to say is in all of this, please focus on the composability as opposed to the canvas. The canvas will keep evolving. This UI is transient. It will be different for different customers as they choose to use it. Instead of the UI, it may just be a plugin into your existing agentic AI IDE like Kiro, Visual Studio, etc. What I want you to think about is the composability. What are the kinds of steps that we're doing in here and what kind of handoffs happen, right? So the first step here, if you saw, is that the question that comes in is really vague, that I want to know how my suppliers are doing. This is the kind of question that you would typically get from a senior business user. And what we're doing here, and this is using in context a combination of source system information, public processes like APQC, etc., is trying to be able to extrapolate from there and get user input about what do you actually mean. Are you talking about supply performance? Are you talking about financial management? Are you talking about quality? What are you talking about, right? The next insight here is to actually put source system context. Because if I take suppliers as an example, it is useless for me to propose or ask all the possible questions and information that I can get about suppliers, because I don't have all the information in the world. I have information in my ERP system, I have information in my distributor management system, I have information in my CRM system. So the first grounding becomes, what systems do you actually want to get this from? Because based on that, we can extrapolate what kinds of metrics, what kind of information, what kind of entities are you actually going to be able to ask and answer. And what that leads up to, and again here, because this is meant to be, again, I said focus on composability, from that information, we are actually able to say, high-level information source system, extrapolate what becomes my requirements. What are the different kinds of business questions that I need to answer? What are their priorities? What are the key entities in that source system where this would come from? And also benchmarking to some industry processes. So in this case, because this is around procurement, we are referencing APQC. APQC is a process framework which looks at how you measure your business across 8 different frameworks. So this is saying that I use conversation like I typically do, but what I'm trying to get out is a very specific requirements which is exploded and is grounded in the customer's own environment, the customer's own systems, and their intent, right? Now, moving further, the next kind of thing that we do is try to propose what are the, given this particular situation, what are the different kinds of analysis that are possible? Again, remember at this stage, we don't know whether this data product is being built for a BI report, it's being built as a flat table for an ML model, it's being built for an AI agent or an API to be able to use. So what we are trying to understand is what is all the way in which you would want to break down this information, and also what is the organization specific term. I am using the word supplier, but some organizations may call them vendors, some may call them partners, some may call them service providers. We want this to be very contextual. So again, all of this is background LLM knowledge saying in this industry what could be different, clarify which things are ambiguous, etc. And we are capturing that because all of this becomes part of that knowledge graph, the context that every agent is writing to and reading from, so that every subsequent agent, by the time we get to creating code, etc., it is very clear about what we are trying to do. And here we also bring the technology side into play because we know that depending on the data structures, if you're talking about, for example, inventory, if you have every inventory transaction, that's going to be very slow for you to query. So we also think about looking, depending on the data profile, recommending or asking questions about aggregations. What do we need to do in order to create performant versions of this data product or have multiple different versions of this from a time perspective? And from an end perspective, if you think about any of you who've gone through this thing about looking at specs for using Gen AI, what we are essentially coming out with here is then the spec for this data product. So the spec includes what is the focus, what are the key the key metrics, what is the architecture that we are trying to do, what are the key kinds of business questions that we are trying to answer, and this is all. And actually, I'll show it to you here as well. So in the summary here, and that also includes, for example, key decisions. Because the decision part becomes important to determine why did I pick doing something. And I've done, I don't know, at least 100, 150 projects of these, typical data platform projects in the last year. The challenge becomes as soon as the project team rolls off and 6 months later somebody wants to know why did we do something, there's no idea, right? It may be in a minute and somebody may have recorded it or not. So all of those kinds of things become important to collect. So the key thing I want you to look at here is that we have gone through the process relatively quickly. This is a process that typically, when we did this with one of our pilot customers, this is a process which typically takes them 3.5 weeks. We compressed it down to around 3 days of time to do this, and that 3 days is because there is elapsed time in the middle. You don't necessarily have the answer to all those questions. You have to go talk to other people in the organization who come and give you that. So this is taking that entire requirement spec, capturing it in a composable manner so that the code that you generate out of this eventually is fungible. It's not, code is not what you want to track, you want to track this. Similarly, especially given, I don't know how many of you guys have seen this recent Snowflake announcements around, having a standards for the semantic model so that everybody is able to have universal definition of semantic models. So again, inside here, and I'm reminding you, we are considering this data products because we are building data products for any reason. So we are actually also determining, based on the questions given, what are the different metrics which would be useful to be added and calculated in this data product. Some of them may be pre-calculated from a performance perspective. Others may be defined in the semantic model because things like ratios, etc., have to be computed on the fly. But we are going ahead providing that. And what then happens in the end here is that we are creating all of the documentation and the context that you can then pass to the actual code generation agents. Because from here, you can go to Kiro, you can go to Visual Studio, you can go to Cloud Code, put this in context, put these in definitions, and what we are computing here, if you see, for example, is what are the silver rare tables that we should be doing to support this? What are the gold layer tables? What are the data quality rules that we should be applying on here? And these are functional data quality rules, because we assume the technical data quality rules, most of the platforms already take care of those right now inside here anyway, right? And that brings me to the second one, which is sort of ops. And when I talk about ops, this is once, so this is, I did not show you the code generation part because I think code generation, I'm happy if you guys come to my booth, I can show you that, but I think that is a very common pattern and I don't think anybody's surprised when you can generate code based on this. My focus again is the fact that we can generate this so you can get to code. The second part around this is in sort of ops, right? So I'm building data products, but I also have to manage them. And if you think about it, the management is a much worse problem because you are accumulating data products that you have to manage over time. And the further away you get from when you first went live, the less information you have about that data product, right? So when we think about this, unified monitoring, and I think this is something that you'll hear everywhere, it's a table stakes item that you have to do. But I want to call out the difference between what we consider platform managed and what we consider customer managed. When you say platform managed, this means that the engineer has no control over how this happens. So we are saying, for example, ingestion and how I do bronze layer processing. And the reason I've separated those two is because in the bronze layer, I might do historization, I might be doing other activities beyond just replicating it. The engineers don't have any control over how it happens. They only have control over configuring what objects that needs to happen for. Similarly, when we talk about generating the DAG, why should an engineer have control over that? DAG generation is based on the dependencies of your silver and gold tables and models. Similarly, with provisioning, Terraform templates, and CI/CD, these are all things that we are saying should be part of a standard platform. You are a consumer as an analytics engineer. You are not contributing or building any of these. But what you are focusing on is ensuring that using the context that we were talking about, your silver gold transformations, if you're using DBT, if you're using Medallion, could be whatever, but I'm taking the example of DBT here, your DBT models are correct, and then all of the infra around how this works in your specific context, either because of network, of integration, VNets, firewalls, etc., are what you focus on. That's the idea behind this, and what this essentially means is that because I have all of that same context, and again, don't focus on the canvas. From a demo perspective, we're doing it in Cloud Code. Practically, we would never expect you to use Cloud Code. We would expect you to use one of these ITSM tools, and each of them has their own agents which can connect to this via MCP to be able to do this. But you now have a single unified way to be able to look at why a pipeline failed, what caused it to fail, change the reason for that failure. In fact, this video is pretty long, but I'm not going to tell you. But re-triggering this, etc., all as well. But the key pattern here becomes that it's not only, the context for this is not only your observability, it is also that entire piece that I showed you in the beginning to say, what does this data product relate to? So if there's a failure, why are we connecting to, I'm sure everybody here has at least one data source, which is some random manual Excel file, which is joined together with other enterprise tools to be able to sum. So why are we connected to that file? What happens if that file is missing a row? All of that context becomes available here as well. So to actually summarize this out, what this means, and we've actually thought about this, this is focused on the build part. There is an equivalent of the manage part, which I'm happy to talk to you separately. The traditional approach is when you're doing requirements, when those people leave, that knowledge leaves, right? It's tribal knowledge. And what we're trying to do is ensure that the knowledge graph that I was showing you captures all of this information, not just the outcome, but also why we got to that outcome. What is the decision point when we got in there? When we talk about validation, it's not just, typically on project, we don't have enough time because we're doing it manually, so we only focus on the typical default checks to say not null, row count between objects, etc. But here, actually do it programmatically by asking for, golden data and actually testing against that golden data so you know that the rules are correct and accurate. Vibe coding generates code, but it does not necessarily generate the correct code. What we are trying to do on the coding side is to say all the power and goodness that LLMs have and agents have, let's supercharge that by ensuring that the context that we are providing to them allows that to be correct. But really the biggest one inside here is instead of manual detective work to determine which table, what join combination gives me this data, I'm using the power of LLMs together with prior documentation, system information, and the ability for me with modern data platforms to be able to spin up, ingest, and actually test in an iterative manner to build out that mapping. And what we have found, and these results are based on the pilots that we've done already, is that building new data products, we are able to get it to, it's around 53% is the difference between the way we would do it manually versus the way that you're doing here. And the main focus of that is, as you can see, not code generation, that is the smallest part. It is really requirements, system analysis, and a little bit on the validation and deployment. Now, as I said, what I was hoping to show you was how we reimagine this. That's what I've gone through here. I'm happy to answer any questions. I think we have 3 minutes left or so. I'm happy to answer questions right now. I'm at booth number E51 if you want to come there and ask questions. If you just want to set up a call for later to actually look at how this would apply in your environment, you can scan that and set up one of these. I was focusing on AI and data engineering. My CTO is going to be doing another talk tomorrow at the Gen AI Theater, focusing on Gen AI in IT, how we've applied it within internally within IT at 2 o'clock. And if you guys are interested, you should come see that. Thank you so much for your time. Yes. Let me. Yes.
In your system, do you have lineage that goes beyond?
We would write into UC. So yes, correct. We would, so whatever we pick up inside, see actually, it depends on whether, this actually is dependent on whether you're live or not. Because when you're live, your DBT model, UC will scan that and pick up the lineage anyway. Okay. But in the pre-requirement step, we can populate that into UC. Unity catalog, that's the Databricks, yeah.
Gotcha, thank you.
No problem. Thank you.